So, have you gone through with the week 2 content? If you have any doubt related to the week 2 content, then ask me. Students, if you have a week 2 content doubts, you can ask me. Am I audible? I think so. Yeah. So, if you have any doubt related to the week 2 content, then ask me. No doubts? No doubts in week 2 content? Okay, so can we solve the questions? Numericals? Okay, watch only 2 videos. We haven't started week 2. Okay. So, any doubt related to week 1? Student, I think better is that class should be interactive.
Sir,
Communication. Yeah.
sir, can an amplifier be used to amplify signals?
Yes, exactly. Basically, the amplifier are categorized in 3 ways. One is the voltage amplifier. Second is current amplifier. And third one is the power amplifier. Okay. Voltage amplifier basically increase the voltage. Okay. But along with that, the power should be constant. Power should be constant. So basically, if voltage will be increases, current should be reduced. Okay. Similarly, in the case of current amplifier, the current should be increases, but power should be constant, so voltage will be reduced. And in the power amplifier, the power is increases. So the voltage is increased as well as the current is also increased. Okay. Now any signal, if I am talking that I am speaking. Okay, so basically my signal spectrum should be like that. Voice signal should be like that. So when I pass through amplifier, the voltage will be increases. Okay, at the same level, the voltage will be increases. Here, if it is a, I say it is a 2 volts and minus 2 volts. So now I'm consider that it is a 5 volt and minus 5 volt. Okay.
Yes, sir. Sir, the op-amp which we are dealing with is the voltage, current, or the power one?
Basically, op-amp is the operation amplifier, that is basically voltage amplifier. Because if you draw the internal diagram, in the first class we discussed that. Okay, this is V1, V2, positive terminal, negative terminal. The voltage up across this one is V1 minus V2. Okay. Now, if we go with the output part, so here we use one particularly source voltage, and the voltage is A time V1 minus V2 with resistor and then output. Okay, so basically the voltage will be increases. The input voltage is V1 minus V2 is the input voltage. We are getting A times V1 minus V2 as a output, and A is voltage gain. Okay,
Yes, sir.
but we can't say that till now we are dealing the operation amplifier, that is the voltage amplifier. Okay, but op-amp is can be used as a voltage amplifier or current amplifier. For both, op-amp can be used for both voltage amplifier as well as the current amplifier.
Sir, are there any specific uses for current and power amplifiers?
Specific uses, the specific uses is that where the we are required mm, basically for the RF to DC converter. Okay, in the RF we are getting the microvolts or microampere current. Now we use this particularly convert into the millivolts and milliampere. Okay, in the RF we are getting the voltage signal that is in microvolt or microampere, and if we are going to convert and useful for the DC purpose, so we have to convert microvolt into the millivolt and microampere into the milliampere. So microvolt to millivolt will be converted through the voltage multiplier circuit. Voltage multiplier circuit. And basically microampere to milliampere, we are using the current amplifier. So where we require the current increase, we have to increase the current where we use the current amplifier. And power amplifier basically for power amplifier we generally use for the electrical points. Okay, for electrical purpose we use the power amplifier class A, class B, class AB amplifier, class C, class D. So there are different type of power amplifiers that are available, but that is used for the electrical purpose. Electrical machineries we are require the power amplifiers. Okay.
Okay, sir.
Any other doubts? Yes. Any other doubts?
Sir, I haven't completed the entire week 2 lectures yet.
Okay. Mm. So basically, you start the week two. Okay. So in the week
Yes, sir.
one, I just brief you about the week two. In the week one, we basically go with the no inverting amplifiers. Okay. In the week two, we go with the inverting amplifiers. Okay. So the output voltage V out is that is equal to minus RF by R1 times V. Okay, this will be providing with the negative or inverting 180-degree phase shift with respect to input. So that's why it is called the inverting amplifier. In the case of no inverting amplifier, we are getting the V naught is equal to 1 plus RF by R1 times V in. No phase shift, that means no inverting. Okay, again, we required a negative feedback for both. Either we are implementing the inverting amplifier or we are implementing the non-inverting amplifier. For the both cases, we required a negative feedback. Okay. In the case of negative feedback, the concept is same. Virtual ground. That means voltage and positive terminal is equal to the voltage at negative terminal. The concept is same. The only difference between the inverting and non-inverting amplifier is in the case of inverting amplifier, our positive terminal is grounded. In the case of negative terminal, we apply the voltage VI, and feedback is also connected with negative. This is output. RF, RA, RB. So output is minus RF by RA times VI. This is inverting. In the case of no inverting, V out, VI, RB plus minus. This is RF, RA. In the case of this one, V naught is equal to 1 plus RF upon RA times VI. This is no inverting. The difference between these two is that in the case of inverting, input is applied at inverting terminal. And in this case, input is applied at non-inverting terminal. This is the difference between the inverting and non-inverting. If you can drive this formula also, okay, you can drive this formula also. So if we apply the inverting, so positive terminal, this is RB grounded. Always remember that when you are solving the operation amplifier questions, you have to apply the KCL. In the most of the cases, apply the KCL. If you don't know anything, apply the nodal analysis or KCL. Clear? So if you see that VI is the voltage that is applied, that is connected with the ground, so no current will be flowing in this one. If this is the VI voltage, so the direction of current will be like this one. This is the direction of current. Any doubt why this is the direction of current?
Because there is no current flowing through the.
Yeah, because we consider the op amp is idle. V positive terminal is equal to V negative terminal. That means the voltage at these two terminals will be equal. If these two voltages will be equal, so when we go with the this particular diagram, yeah, this one. So if V positive is equal to V negative, that means the voltage drop V1 minus V2 is 0. Okay, this voltage drop. If this one is 0, that means this A times V1 minus V2 is equal to 0. And if this voltage source is 0, so current flowing from this one, I out is also 0. Okay. So when we are considering my operation amplifier is a negative feedback, then always we apply the virtual ground concept. According to this one, V positive voltage is equal to V negative voltage. Always remember this thing. Okay. And if these 2 point voltage, this point voltage and this point voltage, if both are same, no current will be passing through the operation amplifier. Okay. Yes, any doubt? Then if no current will be from op amp, all the current will be passing from Vi to V out in this way. Now if I assume that this terminal voltage is Va, now apply the nodal analysis. So current flowing in this direction is this one and the current flowing in this direction is this one. So Vi minus Va, Vi minus Va upon
RA.
Ra. Incoming
Yes.
current at Va point is equal to the outgoing current. Okay.
Plus.
So is equal to Va minus V out upon Rf. Okay, any doubt? Now we know that VA voltage is equal to VB voltage because of virtual ground concept, and VA is equal to VB, and both are zero. Why? Because VB point is connected with ground, so that means the voltage at this point is zero.
0.
Okay, so VA is equal to zero. So VI upon RA is equal to minus V out upon.
RF
This implies V out is equal to
minus of
minus RF by RA
I
times
screen.
VI. Okay, and similar way we can solve for the inverting non-inverting amplifier. So this is the formula for no inverting amplifier. In a similar way, you can apply it for the non-inverting amplifier also. So I can solve. This is the V out. This is the positive terminal. Connected with ground. This is the RA, RF, and RB. Okay. Now I just say that this point is VB point and this point is VA point. Again, the feedback is negative feedback. So we know that VA is equal to.
VB.
Now the thing is that what is the voltage at VB point? Here we know that the current is not flowing from VI to this particularly way. Why? Because VI, if the current will be flowing, this will be going to the operation amplifier, and in the operation amplifier, no current is flowing because operation amplifier is ideal. Second, we connect the negative feedback, so due to the virtual ground concept, no current will be flowing from the operation amplifier. So that means the current in this branch is zero. Okay. If the current in this branch is zero, so that means the voltage drop across RB is again zero. If current is zero, that means VRB is also zero. Okay, and if VRB is zero, so that means I can say that VB is nothing but VI, because all the voltage will be appear at this point. If VRB is not equal to zero, if I say that VRB is not equal to zero, so I can write the equation VB is equal to VI minus VRB. Okay, the voltage input voltage applied minus this the voltage drop across this one. The remaining voltage will be at this point. But we know that the current is zero, so that means the voltage drop across RB resistance is zero. And if voltage drop across RB resistance is zero, that means this particularly point is zero. Okay, so VB is equal to VI. Now, if VB is equal to VI, so we can say the VA is also equal to VI.
Yes, sir.
Now apply the
KCL.
okay. Now we assume that the current flow direction should be like that. Okay, so V0
Minus
minus
VA. B.
VA times RF is equal to VA minus 0 time RA. Okay, and VA is VI. So V0 upon RF is equal to VI upon RF plus V upon RA. I take the LCM, so V0 upon RF is equal to this is the VI. So VI I take a common. LCM is RA into RF. This is the RA plus RF. RF and RF will be cancelled out. Okay, so V0 is equal to VI
1 plus RF by RA.
1 plus RF by
RA.
okay. So this is the inverting and non-inverting amplifier. Now the condition is that right now we assume the voltage, input voltage Vi is applied either on inverting terminal or non-inverting terminal. But we can apply the Vi for both terminal. Inverting and non-inverting terminal. Then we apply the superposition theorem to solve it. I think you are aware with the superposition theorem.
Yes, sir.
Okay, I just brief you that in the case of superposition theorem, we consider one source at a time and other sources, if
Grounded
they are
also.
voltage source, short circuit, and if they are current source, open circuit. Okay, consider one source at a time and other sources, if they are voltage source, so behave as a short circuit, and if they are the current source, behave as a open circuit. Okay, so we apply the superposition theorem to solve these type of problems. I just take one particularly case. Okay. Now, how we solve this type of question?
By using superposition.
By apply the superposition theorem. So first we consider the V1 source. Okay, so V2 will be connected with the grounded. Okay, so this will behave as a non-inverting amplifier. So what is the gain? V naught 1 is equal to 1 plus RF
By
RA times
times
V1. Okay, and when we consider the V2 source, so V02 is equal to minus RF by RA times
times
V2.
P2.
Okay, now V naught is nothing but V naught 1 plus V naught 2, that is 1 plus RF by RA times V1 minus RF by RA times V2. Okay, and that will be equal to 1 plus RF upon RA V1 minus V2. So this is the difference. Okay, this is the difference between these two voltages. So this configuration is called the difference amplifier.
V1 plus.
Yes.
So in place of 1, there is a V1, sir.
Oh, sorry, V1. V1 plus RF upon RA times V1 minus V2. So this is the difference, and this multiply with the amplifier gain RF upon RA. This is the amplifier gain. So this is called the difference amplifier. Okay. Behave as adder. If we apply two or more than two sources, at same terminal, we call the adder. V1, V2, RB, RB minus V0 ground RA RF. So this type of configuration is called the adder. Doesn't mean either it is a connected or a inverting terminal, or it is connected or a no inverting terminal, but a single terminal. Then we call the adder. Now, how we solve this type of questions? Again, we apply the superposition theorem. Can you try to solve it?
Yes, sir. Sir, V out is equal to V1 plus V2 by 2 times RF by RA plus 1.
Okay. So, any other who try to solve that? Any other who try to solve that? No? Okay, so again we solve this one using the superposition theorem. So we consider the one voltage source, RF, RA. Now we consider the V1, negative, positive, V1. Okay, RB. Now second RB is connected with ground. Okay, second RB is connected with ground. So we assume this is the RB. Now we consider two voltage source. One point is this one, so we consider the VB point, and this point is VA point. Yes, anyone? Any doubt? Okay. So we know that due to the negative feedback, it is a considered a virtual ground, and in the case of virtual ground, VA is equal to VB. Okay, and now what is VB voltage? So
V1
the VB voltage is nothing but VI divided by 2. Okay, because the voltage VB voltage is the voltage drop across this resistance, and this resistance both are equal. So the voltage VI will be distributed in two parts. Half will be divided here and half will be distributed here. Drop here. Okay. So the drop across this resistance, RB resistance, the lower one that is connected with ground. So the voltage drop across this one is the VI by 2. So VA is equal to VB is equal to VI by 2. Clear? Any doubt? Now, from the feedback, the direction of current will be this one. Apply ACL. So V naught minus VA upon RF is equal to VA upon RF.
day.
So V naught is equal to VA. V naught upon RF is equal to VA 1 plus RF plus 1 upon RA. Okay, so V naught is equal to VA 1 plus RF by RA. And what is VA? VI by 2. So V naught is equal to VI by 2 or V1 by 2. Yeah, this is the V1. Yeah, V1 by 2. 1 plus RF by R. Now, similarly, if we consider the V2 voltage, consider V2 voltage. So, same effect. This is the V2 RB. This is the RB. Now, the VB is VA is equal to VB is equal to V2 by 2.
V2
Okay, and the same procedure if we apply, so V naught is equal to V2 by 2, 1 plus RF by RF. So this is the V naught 1, V naught 2. Now overall V naught is V naught 1 plus V naught 2, that is equal to V1 by 2, 1 plus RF by RA plus V2 by 2, 1 plus RF by
RL.
RA. Okay, so 1 plus RF by RA I am taking common, so it is a 1 by 2 V1 plus V2. So the voltage will be added, so it is called the adder. So this is called the adder circuit. Now can we solve the question? 2 volt, 3 volt, 2 kilo ohm, 4 kilo ohm, 10 kilo ohm, and 40. Find the V out.
Sir, 11.66 volt.
11.66. Any other? Yes, any other who tried? Any other solve this one?
Yes, sir.
Okay. So what is the answer?
11.66.
Okay. Any other answer? $11.6. Okay. Anyone who can't solve this question? Or should I explain how to solve this type of question? Anyone who is can't able to solve this question? Student, please speak. If you can't speak, I can't
Sir,
say.
can you explain?
Okay. Okay, I will explain. So basically, we consider two voltage source. So first we consider 2 volts. So 2 volts, 2 kilo ohm, positive terminal. Now the 4 kilo ohm will be grounded. So I just consider that this is the 4 kilo ohm. Okay. This is negative. V out. Okay. Now first of all, the voltage at this point. I just consider this as a VB. This is VA. So VA is equal to VB is equal to. Now what is the voltage if 2 volt will be drop across 2 kilo ohm and 4 kilo ohm? So we apply the voltage divider by C.
Yes, sir.
Okay. And this, so what is the voltage divided by C? Say the
4
VB is
by,
equal to 4 divided by 2 plus 4 into 2 volts.
yeah.
Okay. So 4 by 6 into 2 volts. So it is a 8 by 6 volt. Okay. Now this VB and VA both are same. Now it is a 10K. It is a 40K. So now can I apply the formula? So V out is directly 1 plus 40 divided by 10. K and K will be cancelled out. Multiply by 8 by 6. Okay, so it is a 5 into 8 by 6. So 40 by 6. Okay, now we consider the 3 volts. So 3 volts, 4K, 2 kilo ohm, positive terminal, the negative, it is a grounded, 10K, 40K, V node. Now
Sir,
again, this is the VB. Yeah,
sir, when we are dealing with the 3 volt,
Hmm.
2 kilo ohm will be grounded, right?
Sorry. Yes. This is the 4K and this is the 2K. Okay. Now again, the VA is equal to VB. Again, we calculate 2 divided by 2 plus 4 times 3 volts. Okay, so 2 divided by 6 into 3. So that is 1 volt. So VA is equal to VB is equal to 1 volt. Now V naught 1 plus 40 divided by 10 multiplied by 1 volt. So it is a 5. So overall answer is, if this is a V01, V02, so V naught is equal to 40 divided by 6 plus 5. So that is 70 divided by 6. So 11.664.
So, so,
Okay? Yeah.
we cannot apply the like KVL in the to solve the VA like 2 volt.
VA. Yeah, you can
Yeah.
apply the KVL. Na? You can apply the KCL or KVL basically.
So
So
we do not need supervision. We can replace.
superposition, actually the purpose of using the superposition is that here the question is easy. Okay. But if we are considering the negative terminal also, so best way is the you apply the superposition. That's why I use the same method to apply the superposition every time.
Okay.
Okay?
Sir,
Yeah.
what if, sir, if there are more than 2 voltages?
Yeah, we can apply the same method. We can use the same method. I am using the same question. Negative terminal. Fifty kilo ohm, 10 kilo ohm, that is grounded. Three volt, 5 volt, 4 volt, 4 kilo ohm, 2 kilo ohm, and 2 kilo ohm. Okay, calculate the V out. The method is same. One is particularly considered and two voltages will be the grounded. Now, if like for example, if we consider the 5 volt and 4 volt are grounded, so basically these two will be connected with the ground in a parallel combination. Okay, just try to solve it. Should I consider? I just take a one particularly. So if I consider 3 volts, so 3 volt, 4 kilo ohm, positive terminal. At this point, we are considering the two resistors. One is 2K, another is 2K. V naught. Okay. Now this parallel combination will be created 1 kilo ohm. So either we use 2 kilo ohm or we are consider the 1 kilo ohm in a parallel. Okay. So this point is VB. This point is VA. So VA is equal to VB is equal to, now we have to apply the voltage divider by sir. So drop across 1 divided by 1 plus 4 multiply by 3 volts. Okay. So it is a 3 by 5. Now if VA is 3 by 5, so V out is what? 1 plus 50 divided by 10 into 3 by 5. So it is a 18 by 5. This is the V naught one. Similarly, if we consider the 5 volt, the 2 and 4 kilo ohm are in parallel and connected with the ground. Okay. So for one voltage, I can just calculate. For 3 and 5 volt, you calculate, find the value of V out. Just tell me what is V out. So yes, what is V out?
Sir, 24.9.
24.9. Okay.
Mine is coming 25.2.
25.2. Okay, so two answers, 24.9 and 25.2. Any other? Yes, any other answer? 24.9 and 25.2. Okay, let's check. So for the 3 volts, we already calculated. Now we go with the 5 volt. So 2 kilo ohm is the resistance. 4K and 2K are connected with ground. Plus minus is 10K 50K V out. This is VB, VA. So VA is equal to VB is equal to 2K and 4K parallel combination. So it is a
4 by
4
3.
by 4 by 3 divided by
2
2
plus
plus 4 by 3 times 5
5.
volt. Okay. Similarly for the 4 volt also same. So VA is equal to VB. The structure is same, so that is 4 by 3 upon 2 plus 4 by 3 times 4 volt. Okay, so that is for 5 volt and that is for 4 volt. So it is 4 divided by
10.
10 into 5, so it is a 2 volts. It is a 4 divided by 10 into 4, that is 1.6 volt. Okay, so V02 is equal to 1 plus 50 divided by 10 times 2 volts, so this is our 12 volts. V03 is 1 plus 50 divided by 10 into 1.6, so 9.6 volt. So 12 plus 9.6 plus 1 is 3.6. So it is at 25.2 volts. So 25.2 is correct. 24.9. What is the mistake you are doing?
Sir, I am converting into decimal, sir. So that's
Decimals.
yes, sir. 4 by 3, I approximate it as a 1.33 and
Okay.
yes, sir. 10 by 3, I approximate it as
3.33. 3.33 volt. Okay. Okay. Now, similar type of question if we are connecting the two sources on a non-inverting terminal. Sorry, inverting terminal. So this is the positive, grounded. Now we connect two voltage V1 and V2. Minus R B RA1 RA2. This is V out R. Okay, so the method is same. No role of this RB. So V out is directly minus because of this V1 source. So this is the RF by RA1 times V1, and because of this V2 source, RF by RA2 times V2. Okay. V out V1 V2 V3. In place of V1 V2 V3, I just put as a 2 volts 3 volts, 4 volts, 2K, 4 kilo ohm, 8 kilo ohm, 32K, 10 kilo ohm.
Negative 72 volts.
How much?
Negative 72 volts. Minus of
Negative 17 volts,
72.
72. Any other answers?
So
Yeah,
I had a doubt.
yeah.
So if we use superposition and we connect 3 volt to the ground and 4 volt to the ground
Mm-hmm.
and 2 volt is applied, okay. So
Mm-hmm.
high current will follow through the 32 kilo ohm resistor to be out. It will go
Yeah.
like K to 4 or 8 to combination to the ground.
Okay, I will just tell you.
Okay.
Okay, I understand. Uh, yeah. The thing is that if we connected 2 volts, like for example, my positive terminal is which is 10 kilo ohm, my 2 volts is connected with this. Now my 3 and 4 volt will be grounded because we apply the superposition here. So 3 volt is this one and 4 volts. So 4K and 8K. We are. Okay. So is there any effect because of this 4K and 8K? Is it your question?
What?
There is no effect of this 4K and 8K. Why? This is your question, I think so.
No, like current. What the path will current follow?
Okay. So basically, the thing is that when we are connected the negative terminal, so here what is the voltage? This VB voltage is 0. Okay. That means at this point the voltage is VA is 0.
Zero.
This voltage and this voltage is same. So VA is 0. Clear? If this is
Yes.
0, this is grounded, so that means no current will be flow from here. Similarly, if this point is 0 and this is grounded, so no current will be flow from here. That means either I connect these two resistance or I am not connecting these two resistance, there is no effect. Okay.
Okay.
But
Okay.
similar case, if I connected voltage, it will be creating the effect. But when I connect the negative terminal voltage, so there is no effect of other two resistors. Why? Because of this particularly point should be 0. The voltage at this point is 0. Now if I connect with the grounded, like if I connect with the grounded, this is the grounded. Here is the voltage is also 0. So 0 and 0 voltage, same voltage drop. So no current flow will be here. No current flow
Got
will
it.
be here. So what is the direction of current? The current will be flowing from this to this one. Okay. So the current
Yes.
direction is from this to. Okay. That's why these 4K and 8K parallel combination doesn't create any effect. So that's why I'm writing directly the, because of 2 volts we are getting the V naught 1, that is equal to minus RF. RF is 32 divided by 2 times 2 volts. So it is a minus 32 volts. Similarly, with respect to the 3 volts, we are getting a V02 is equal to minus 32 divided by 4 into 3 volts. So it is a minus 24 volt. And V03 is minus 32 divided by 8 into 4. So it is a minus 16 volt. So overall addition is 40 and 72 volts. Okay. So if I connected a multiple resistance on a negative terminal, one particularly voltage source that is basically used in a superposition theorem, that's create the resistance across connected across this one will be create a effect. Other resistance doesn't affect. Okay. But when I connected on a positive terminal, the other resistance will be creating the effect. This will be drop down the voltage level. Okay, this will be drop down the voltage level. So this is the difference between when I connected in a positive terminal and when I connected on a negative terminal. Clear?
Sir,
Yes.
sir, we can approach this question as using KCL, sir. In the
Yeah, you can apply with the KCL also, no
sum,
issue.
sum of all currents
Yeah,
in at a point is zero.
yes, exactly. So basically the current in this one is I1, the current in this branch is I2. I just consider this is the I1 current, this is the I2 current, this is the I3 current. Okay, this is 0
Yes.
point and all current will be going in this one. So incoming current is I1 plus I2 plus I3 is equal to I
V
out.
out by 3. Yes, sir.
Okay, so what is I1? 2
1.
divided by 2 plus 3 divided by 4 plus 4 divided by 8. Okay, because the voltage drop divided by the resistance, that is I1 I plus I2 plus I3, that is equal to minus of
V out by
V
32.
naught by 32. Okay, so V naught is minus 32, 1 plus 1 by 2 plus 3 by 4. So it is a 2.25 times 32. So minus 64 minus 8. That is minus
minus
7.
72.
32 multiplied by 2 is 64 and 32 multiplied by 0.25 is minus 8. 64 and 8 is 70. Okay.
Yes.
Yes, sir.
Now we can use this same thing, like now I connect a V1 4 volt positive terminal. Now 2 volts this is 4 volt 2 kilo ohm 2 kilo ohm 4 kilo ohm 16 kilo ohm. Now calculate the V node.
Is it 42 volt?
42 volts. Okay. Any other? Any other?
Sir, 14 volt. 1 4.
40 volt?
40 volts. Okay. Any other?
1 4, sir. 14.
How much? 41.
Sir, 1 4, 14.
How much?
14, sir. 14. 1 4.
14. 1 4. Just any other? minus 32. Any other? Okay. So first we apply the 4 volt and remaining 2 will be the grounded. So the circuit should be like that. 4 volt, 2 kilo ohm, positive on the grounded.
Sir, answer is 20 volt.
Answer is 20 volt. Plus or minus?
Plus.
Okay, plus 20 volts.
Sir,
Okay,
24. Sir, 24.
24. So here we are connected to particular resistance. And this is my V naught. Okay, 16K, 2K and 4K. Now no current will be going inside the operation amplifier. So that means at this point the voltage is 4 volt. So similarly the voltage at this point is 4 volt. Okay. Now the direction of current will be in this way. So V naught minus 4 volt divided by 16K is equal to 4 minus 0 divided by the parallel combination of 2 and 4, that is 4 by 3. Okay, so V naught by 16K is equal to
3.
4 divided by 16K plus 4 divided by 4 by 3K. Okay, so V naught is equal to 16, 4 divided by 16K plus, so it is a 12 by 4. Okay, 16. So V naught is 4 plus 48, 52 volts. Okay, so I consider that a V naught 1. That is 52 volts. Is it okay? Any doubt?
Okay, sir.
So first voltage V naught 1 is 52 volts. Mention it here. So that imply V naught 1 is 52 volts. Now we apply 2 volts. So this is 2 kilo ohm grounded, connected with positive terminals, negative 2 volts, 2 kilo ohm, 4 kilo ohm, this is V naught. So V naught 2. Okay, So this point is 0 volts. So this point is 0 volt and this point is 0 volt. So 0 and 0 grounded, that means no current will be flowing from this resistors. So can I remove this one or no changes? Okay. So the direction of current will be from this one to this one. So V02 is minus RF by R1 times 2 volts. So minus 16 divided by 2 into 2 volts. So minus 16 volts. Okay. And similarly, if we connect a third voltage source, so the same circuit is same. Okay, only changes is what? Here we connect a 4 volt. This is the 2 kilo ohm, 4 kilo ohm. Yeah. Okay. This is a 16K. So V03 is minus RF by R1 into 4 volt. That is minus 16 divided by 4 into 4 volts. So minus 16 volt. So V naught is V naught 1 plus V naught 2 plus V naught 3. So 52 minus 16 minus 16.
20.
That is 20 volts. Okay, so the correct answer is 20 volts. Okay. Any doubt in this type of questions? Any doubts of this type of questions?
No, sir.
Okay. So I think we will just stop here. If you have any doubt now, you can ask me. Student, I just want to ask, is it easily understandable what I am talking, what I am teaching, or the pace should be slow or pace should be high?
Okay, sir. Is it good?
Is it okay?
So it's okay, sir.
Yes, sir.
Okay. So I think you are understandable.
Yes, sir. Thank you, sir.
So,
Yeah.
is this circuit like inverting or non-inverting?
Which one?
This current one.
Last one.
Yeah.
Here we are connecting the voltage at a inverting and non-inverting both. So it is a combination of adder and different circuit, not a non-inverting and non-inverting. Okay, but we are getting the output voltage is the positive. So in this way, we can say the circuit is the non-inverting circuit amplifier.
Okay. So approach will be like we will find the BB, and then we ground the both the voltage source on the inverting point, and then we ground one and then ground other, and we'll found the V out.
Yeah, we convert this one into the three different scenarios where
Yeah.
one in the first circuit we are this is behave as a non-inverting. In the circuit second and third it will behave as the inverting circuit. So it is a combination of inverting and non-inverting amplifier. Okay, so we call this type of circuit as a mixer circuit.
Okay.
This is a combination of adder as well as the difference circuit.
Okay.
Adder is what? These two voltage will be added. They are negative, but these two voltage will be added up. Minus 16 and minus 16 we have added. That's why it is a minus 32. Okay. And that particularly minus 32 and this two, so this one is again a add up. So we are getting a 20 volts. Okay. Or we can say the 52 will be minus with 32 volts. So we are saying that it is a combination of adder as well as the subtractor. Different circuit. Okay.
Okay, sir.
Now we are getting the output voltage that is positive, 20 volts. So on the basis of this one, we say that it is a non-inverting amplifier. Why non-inverting? Because we are getting a positive voltage at a output, so it behave as a non-inverting. If we are getting a negative voltage at a output like minus 20, we are getting, so we can say that it is a non-inverting amplifier.
Okay, sir.
Anything else?
No, sir.